Good morning, student. Today we'll discuss the closed loop control systems. We have been discussing about the control system, and yesterday we have seen that there are these theories. We have discussed the classical control theory, how this control theories evolve with the centuries. So classical control theory, then modern control theory, robust control theory, and automatic control theory. And these theories, they are generally used find applications in engineering and science. And for industrial applications, the control theory is used for involving control of temperature, pressure, humidity, and flow, etc. And we have seen in 18th century, James Watt has developed the centrifugal governor for controlling the speed of the uh, in govern for controlling the speed of the engine. Okay, so for controlling the speed of the steam engine. Okay. So centrifugal governor for controlling the speed of the steam engine in 18th century, and in 1922 Minorski worked on the automatic controller for stepping for steering the ships and show how the stability could be determined from the differential equations. And we have seen how the control system is evolved, and the modern control theory, which is again based on the time domain analysis of the differential equation of the system. And therefore we have seen how the uh, system is there, how the control system is consist of the different component, they are connected in such a way so as to direct, regulate, or command the behavior of the other system. And therefore we have yesterday we have taken the example of the car. Suppose we expected speed of the car is 60 km/h, and therefore if the actual speed of the car is 40, then we have to accelerate the pedal, so that accelerate the engine with the help of the pedal. We will apply the more force on the pedal, and therefore whenever we accelerate, the more fuel is given to the engine, and therefore more output will be there, and we can reach up to the expected value. And there are the different approach for the analysis of the control system. We may use this frequency response approach or the time response approach. And yesterday we have discussed the basic terminology, that is control variable and control signal. Control variable we have discussed, it is a quantity to be measured or controlled. And the control signal, or it is also called as the manipulated signal. It is the quantity which is varied by the controller. Okay, so that is called as the control signal. And control variable is the quantity uh, which is to be measured or controlled. Okay, so the quantity which is to be varied by controller, and when quantity is varied by the controller actuate the plants. The plants may be machine equipments, it may be the DC machine, armature control, feed control. Okay, so here we have to control the speed of the plant. Plant means machine. Okay, so we have discussed the process also, and the systems disturbance. It may be the internal disturbance or the outward disturbance. And yesterday we have discussed the feedback control. Okay, the closed loop control system or feedback systems. So in this case, the feedback is there. Okay, so this is the feedback control system, the system that maintains the relationship between output and input. Okay, and the reference input by comparing them. Okay, So a system that maintains the a prescribed relationship between output and input, between the output and this is output and this is a reference input, and we are comparing this. If there is error, then error is generated, and that error generated it is given to the controller, and this is called as the, if there is a feedback is provided to the system, that's why it is called as the feedback control system. The example yesterday we have discussed, that is a room temperature control system. So by measuring the actual room temperature of the system, we can check so feedback control system, we have discussed that the temperature, we have to measure the temperature of the room, and according to what is the temperature and what we expect, so that is the feedback control system, where the thermostat is there, thermostat device is there, which will turn the heating or cooling equipments on and off. Heating equipments is also there, cooling equipment is also there in the AC, and therefore this thermostat is having the function to turn on and off these cooling or heating equipments in such a way to ensure that the room temperature remains at a comfortable level. We have to maintain the room temperature at a comfortable level, and therefore this we have yesterday discussed the feedback control system. Now we'll discuss the closed loop control system. The feedback control systems is often referred to as closed loop control system. Feedback control system is often referred to as closed loop systems, or feedback control and closed loop control system, they are interchangeably, and therefore in practice the term feedback control and closed loop system generally it is used there. In a closed loop control system, the actuating error signal is the difference between input signal and the feedback signal. Same in the closed loop control system is also the actuating error signal. This is actuating error signal. This is actuating error signal, which is the difference between the reference input and feedback. Reference input and feedback may be the output signal itself or a function of output signal and its derivatives, and it is fed to the controller, okay, so as to reduce the error and bring the output to the system of a desired value. Okay, so the closed loop control system is also similar to the feedback control system, where the actuating error signal, which is the difference between input and output input signal and feedback signal, may be the output signal itself or a function of the output signal, and it is fed to the controller so as to reduce the error to bring the output system to the desired value. So here, if you draw the block diagram for this control system, it will be again same. This is again controller. Here may be your plant or system of which you are going to control something, some values, and this is a feedback, and it is given to comparator. This is reference input, and this is a actuating error signal. Okay, so this is actuating error signal. It is given to the controller. Controller will actuate the system in such a way so as to give the plan. So this is the also the block diagram of the closed loop control system. The term closed loop always simplifies the use of feedback control action. Okay, so here the control action is depends on the output. That's why it is called as the closed loop control system. Whatever the control action is there in this controller, that is depends on this output, which is taken from the output, and it is compared with the reference input. Whatever the error signal is generated, it is given to the actuator. So this is a controller, and controller will actuate the system in such a way so that you can obtain the output which is very close to the desired output. Okay, so this is about the closed loop system. Now suppose what are the examples of the closed loop control system? There are the numerous examples of the closed loop control system. I will give one such example, that the person walking on a street with his eyes open. Okay, so when the person is walking on the street with his eyes open, so for example, he wants to head in the east direction, and suppose he has closed his eyes and he continued to walk for a while, and it may be possible that he may not head in the east direction because his eyes are closed. He may turn to the north direction, he may turn to the south direction or the west direction after some time. But if his eyes are open, then he will continuously get the feedback whether he is going in the right direction or not. So if his eyes are open, that means he will get the signal from the eyes. Eyes signal will be sent to the brain, and brain will give the signal to the leg to move or to walk in the proper direction. So in this way, the eyes is functioning as a just like a feedback. Okay, so this is the closed loop control system. This is an example of the closed loop control system. So another example, suppose his eyes are closed, what will happen? He will not get the feedback. So that means it will become the open loop control system. If his eyes are closed, then this will become the open loop control system. So those system in which the output has no effect on the control action, because there is no feedback, and therefore the output is not have any effect on the control action in case of the open loop system, and therefore your block diagram of the system may be like this. As there is no comparator, it is a controller is there. Here is the reference input, and it is given to the plant or the your system, and here it is the output. So in the open loop control system, there is no feedback at all. So whatever the input is given to the system and whatever the output is giving the system, that we have to accept, because in this case the controller action is independent of the output. It is not dependent on the output. So for example, example of this open loop system. Okay, the person who is walking on the street with his eyes closed. A person walking on street is an example of open loop control system. Okay, why? Because we have to also give the justification, because he will not get the feedback if his eyes person walking on a street with his eyes closed, is an example of the open loop control system, because he will not get the feedback, and whenever the system is not having any feedback, That means it is an open loop control system. So the open loop control system, the output is neither measure nor feedback for comparison with the input. Okay. In this case, the output is not measure or also compared with the input. So output is no doubt we have to measure the output, whatever the output the system is given, but we are not measuring the output just for the sake of the comparison purpose. Okay, so there is whatever the input is given to the system, open loop system, whatever the output is we are getting, that we have to accept. There is no chance of comparing the output with the input and the controller. Okay, so therefore such type of the system, controller will actuate, means suppose we want more output, we have to actuate the system, but there is no as such provision for the comparison of the input with the reference output with the reference input signal. Okay, so another examples of the closed loop control system is the we are discussing open loop control system. Another example of the open loop control system is the washing machine. So what we do in the washing machine? In washing machine, we have the dirty cloths. Okay, then there is a soaking, washing and rinsing in the washer, operate on the time basis. What is the input to this washing machine? Detergent powder. Okay, and detergent powder, dirty cloths, and the operation of the machine. What are the operation of the machine? It may be the soaking, then it is washing, after it is washed, then it is a rinsing, and after that your clothes will be clean. But there is no guarantee whether your clothes are clean, because there is no provision whether the clothes are clean or dirty. After some time, this is all will based on the time. The soaking, washing and rinsing, it is the time is set in the washing machine for suppose 10 minutes or 20 minutes. It will do all these operations, soaking, washing and rinsing. Once you provide the dirty cloths and powder input to the machine, it will take the water automatically, and it will do these functions for some time, suppose 20 minutes, depending on. So after 20 minutes, the machine will stop and will get the cloth, and there is no guarantee whether the cloths are clean or dirty. Okay, that means this machine is not taking the output of the system into the consideration. That's why it is a open loop control system, and machine does not measure the output signal, that is the cleanliness of the cloths. So in any open loop control system, the output is not compared with the reference input, and therefore to each reference input there correspond a fixed operating conditions. Okay, so accuracy of the system depends on calibration. What about this accuracy of the system? The accuracy of this system depends upon the calibration. When the equipment is calibrated, whatever the output the system is giving, we have to accept. So output is depending upon the calibration of the equipments. Okay, then the open loop control system can be used in practice only if the relationship between input and output is known, and if there is no internal or external disturbances, because this system is very simple and it is also economical system as compared to the closed loop control system. Closed loop control system is a very complicated system, and it will also costly system. Okay, so the open loop control system used in practice only if the relationship between input and output is known, and if there are neither internal nor external disturbances. Okay, therefore such systems are not feedback control system. Control system that operates on the time basis is an open loop system. Okay, the control system that operates on a time basis is open loop system. So control system that operates, so the washing machine, it is also operating on time basis. For 20 minutes the machine will operate. Another example is the street lighting, or it may be the traffic signal, not traffic signal. So traffic signals are there, and in traffic signal at the square, okay, so some vehicles are coming on this sides, some vehicles are also coming on this, some vehicles are also coming. So at this square, so what happens, the vehicles are coming, so there are the signal from this side. So if these signals they are operating on the time base, then this is traffic signal which is operating on time base. If it is operating on the time base, then it will be the example of the open loop control system. If the traffic signal is not operating on time base, and if it is considering the density of the vehicle from that side, then it will be the example of the closed loop control system. Means whenever the system is taking the output into consideration, that will become the closed loop control system. But if it is not taking the output into the if it is taking output into the consideration, that will be the closed loop control system. If not taking, it will be the open loop control system. Or the if this system based on the time, for suppose 10 minutes this signal will be on, after completion of the 10 minutes this signal will automatically off. So this system will be this system is now based on the time, and therefore this is the example of the open loop control system. So we'll see what are the advantages as well as disadvantages of this both the systems. The advantage of the open loop system, we can say it is a very simple system, economical system, but stability problem is there. That is the disadvantage of the open loop control system. Whereas the advantage of closed loop control system is that the feedback makes the system response relatively insensitive. The use of feedback makes the system response relatively insensitive to the external disturbance and internal variation in the system parameters. So whenever there is internal variation in the system or the external disturbances are to the system, that closed loop system is relatively insensitive to these disturbances as well as variation in the internal system, in parameter variation or something like that. So that is the advantage of closed loop control system. Therefore, thus it is possible to use the relatively inaccurate and inexpensive components to obtain the accurate control of a given system. It is not like that we should have the expensive components or accurate components while designing the control system. We can have relatively inaccurate or inexpensive components to obtain the accurate control of the given plant. Why we require the inexpensive and inaccurate components? Because there is a provision for checking the output with the input. Okay, and your system is also relatively less sensitive to the external disturbance and internal variation. So that is the advantage of closed loop control system. So from the point of view of stability, we can say the open loop control system is easier to build because of the system stability is not the major problem. Okay, in case of the open loop control system, it is easier to build a system, open loop system, because the system stability is not a major problem. On the other hand, the stability is a major problem in the closed loop control system, because we are taking the output and we are comparing with the reference input, and therefore error signal is generated, it is given to the actuator, and therefore while doing so the stability of the system may be loose. Okay, we can lose the stability of the system, and again we have to stabilize the systems. Okay, so that is the disadvantage of the closed loop control system, means the stability problem is there. And if it is means we have to emphasize that the system in which the inputs are known. Suppose we have to design the system for any plant, and if you know the inputs ahead of the time, what is the input you are giving to the system, and if you know the inputs ahead of the time and in which there are no disturbance, it is advisable to use the open loop control system. Okay, if the inputs are known ahead of time and if there are no disturbances, in the system, it is advisable to use open loop control system. Okay. Because we are knowing what input we are giving to the system, what are the and we know that there are no disturbances in the system, and therefore it is advisable to use the open loop control system. But if you do not know the time, if you do not know the input ahead of the time, means we don't know what type of the input we are giving to the system, and we also don't know and if there are the disturbance in the system, if the input is not known ahead of the time and if there are the disturbance in the system, then we have to use the closed loop control system, and there is no option to this. We have to go for the closed loop control system. So closed loop control system have the advantage only when unpredictable disturbances or we can say unpredictable variation in the system components are present. Okay, so whenever there is unpredictable disturbances are there, or unpredictable variation in the parameter of the internal system is there, then it is advisable to use the closed loop control system. And next, the output power rating partially determine the cost, weight, and size of the control system. The number of components which are used in the closed loop control system is more than that of the corresponding open loop control system. Obviously, because a closed loop control system is a complicated system, definitely it will require the more components as compared to the open loop control system. The closed loop system is generally higher in cost, also power, and to decrease the required power of the system, open loop control system may be used wherever applicable. Okay, so the proper combination of open loop and closed loop system is usually the less expensive and will give satisfactory overall system performance. So the major advantage of open loop control system are simple construction and ease of maintenance, less expensive than the closed loop control system. There is no stability problem in case of the open loop control system. Okay, so these are some advantages. So major disadvantage of the open loop control system is that disturbance and changes in calibration causes error, because once the equipment is calibrated, whatever the output the open loop system is giving, we have to accept. And therefore that is the disadvantage of this open loop control system, that if there is a disturbance and changes in the calibration of the equipment, then it will cause the errors and the output may be different from the what is we expect. Output may be different from what we expect. And to maintain the required quality in the output, recalibration is necessary from time to time. Okay, that is the disadvantage of the open loop control system. So to maintain the required quality output, suppose we have to maintain the required quality output, we have to recalibrate these components of the open loop control system from time to time. So this is the examples of the definitions and the examples of the open loop, as well as advantage and disadvantage of the open loop and closed loop control systems. So it is very always question is there, what do you mean by open loop and closed loop control system, and therefore we have to define this open loop and closed loop system. The open loop system in which the control action is independent of the output, okay, and in the closed loop system the control action of the controller is dependent on the output of the systems. And therefore we have to draw the block diagram of the open loop and closed loop control system. We have to also explain it with one example of open loop and closed loop control system, and then we have to also mention the advantages as well as disadvantages from the point of view of its construction, from the point of view of its economy, okay, maintenance, stability. In this way we have to just write down the all the points details in details. So I think that we have got about the open loop and closed loop control system. Are you getting what I am? Yes. Are you getting? समजताय का तुम्हाला?
Yes, sir.
Okay. If you do not get, you can ask. Okay. So this is the example of the open loop and closed loop control system. And next we'll discuss the Laplace transform. Okay, because this is the tool, mathematical tool we are going to use in the analysis of the control system. And here the student who has the strong mathematical background, he will be on the top of this analysis of the control system. So here the Laplace transform. It is a mathematical tool. It is very easy, and therefore Laplace transform method is an operational method. This is an operational method that can be used advantageously for solving the linear differential equation. We have also seen in the mathematics. We use the Laplace transform to solve the linear differential equation. And by the use of Laplace, we can convert the common function. What are the common functions? Common functions are, for example, it may be the sinusoidal function. This is commonly used. That's why it is called as the common function. Sinusoidal functions. Then there is a damped sinusoidal function. Damped sinusoidal function. Then there are the exponential function. And therefore the Laplace transform is used to convert these common function, such as the sinusoidal function, damped sinusoidal function, exponential function, into the algebraic function. we have to convert this into the algebraic function. Algebraic function of a complex variable. Yes. And therefore, the operations such as the differentiation and integration can be replaced by the algebraic operations in the complex plane. Therefore, the linear differential equation can be transformed into the algebraic equation in a complex variable S. And if the algebraic equation in S is solved for the dependent variable, then the solution of the differential equation may be found by the use of the Laplace transform. So the advantage of the Laplace transform method is that it allows the use of graphical techniques, okay, for predicting the system performance without actually solving the system differential equation. And the another advantage of Laplace transform method is that when you solve the differential equation, both transient component and steady state component of the solution can be obtained simultaneously. So whenever the system is subjected to the any input, then system is subjected to the transient will occur in the systems, and therefore after some time the transient will disappear and your system will be reach into the steady state condition. And therefore whenever the different input is applied to the systems, and therefore this Laplace transform method is useful to solve the differential equation, both the transient component and steady state component of the solution can be obtained simultaneously. So this is the Laplace transform will check the Laplace transformation is generally denoted by the function that is f of t. Suppose f of t is a function of time t. What is f of t? It is a function of time t such that f of t is equal to 0, and this is 0 for time t is less than 0. So this function f of t is 0 for the time t is less than 0, and therefore this S is a complex variable. S is the complex variable. We can write this complex variable like this: S is equal to sigma plus j omega. So sigma is the real part, this omega is the imaginary part. So here sigma is the real part and omega is the imaginary part. And next is we have to use the prefix like this. This L is an operational symbol. This is a operational symbol indicating the quantity that it prefix. Is to transform by the Laplace integral, and this Laplace integral is nothing but 0 to infinity this e raised to power minus st into dt. Okay, so whenever such operation symbol is there, it means we have to, it is indication that the quantity that is prefix is to be transformed by the Laplace integral of 0 to infinity e raised to power minus st into dt. Okay, and this f of s, what is f of s? F of s, this f is the Laplace transform of f of t. It is a Laplace transform of f of t. Okay, so the Laplace transform of this, it is given. So this is the Laplace transform of f of t, which is equal to f of s, just we have written, and this is f is equal to 0 to infinity e raised to power minus st dt into f of t, and therefore this we can write 0 to infinity f of t into e raised to power minus et into dt, and this is a Laplace transform of f of t, which is also equal to f of s. Okay, so but the reverse process of this is, now here we have converted the time domain function into the s domain, but the reverse process of finding the time function, if you find the inverse Laplace of this, you will get the function in time. Okay, so reverse process of finding the time function f of t can also be found from the f of s. Therefore this is a reverse process, and this process is called as the inverse Laplace transform. We can also invert this into the time domain. So this is called as the inverse Laplace transform, and therefore the operational symbol for this is used